Okay, in this video, what we're going to do is get all of our headers written. Now, we're going to start out with the SDL demo that's stripped down that we've used in, well, several of our applications now.
That's right.
Again, just to save a lot of time on typing stuff we've seen over and over and over. You'll notice with a quick look right there with our includes, we're already including our list box, our button, and our slider.
Because we'll be using these.
That's right. And, of course, we've got GL engine and everything else as well. You can also see at the bottom, bool navigating equals false. Obviously, our navigating is in place as well.
Yep.
Go ahead and launch it real quick, Joel, just so that they can see. It is indeed a stripped-down window.
In other words, we can't see anything.
That's right. With only the OpenGL demo text and the frames per second up in the upper right-hand corner. So that's it. So very easy for you guys to get into this situation. Just make some modifications, pull some things out, and you'll be ready to rock and roll.
That's right.
So now, for us, let's begin adding headers.
So let's go ahead, and I'm going to create a new folder in here, and I'm going to call this scene. And I'm going to create the same inside of my source files, basically just to allow us to spread everything up. So we can have our scene graph stuff in separate folders.
Yeah, split it all up, keep things organized.
That's right. So we're going to add a new item. And our header file, this is going to be our node. So our node header file, I'm just going to add in all the header files we need. And we have our transform node.
Then our mesh.
Our mesh.
Our primitive. Our cube.
Cube.
And our plane.
And these are all the classes that we said we would be creating in the last intro video.
That's right. You want to go ahead and make all the CPPs as well.
Let me just move down so I can see it. All right. So new item for our CPP. And this is going to be our node, our transform, our mesh. And we also have our primitive. And we have our cube and plane. All right, so there we go. All of our header files and CPP files that we need. Let me go ahead and go all the way over to here and start with our node header file.
Let's get all of the if not defined defines in place.
So we're going to have our if not defined. You'll notice that I'm going to be creating these kind of in the order of our scene hierarchy. So our node, our transform, our mesh, our primitive is a child of mesh, cube is a child of primitive, and plane is a child of primitive.
That's right.
So just kind of going in order here. So our node. So let's go ahead and define our node underscore h and end our if. End our if. All right. So our class node. Let me go ahead and block this in. Put our semicolon. Now we're going to need quite a few things inside of this. Go ahead and define these out. We're going to need our node header, our constructor. And we're going to create a virtual destructor. As I mentioned quite a few times in some of the other videos, because we're inheriting from this node class, make sure you make this virtual so the proper destructors are called. And we talked about we're going to need parenting. So let's go ahead and create a set parent. Yeah, some functions to handle this. And we'll pass a pointer to the node that we want to be our parent.
That's right. And we'll go ahead and do get parent.
Right. This is going to be necessary if we want to, well, get our current parent.
That's right. And obviously you can see it returns a node.
And let me go ahead and go to our protected section. And we're defining this as protected simply because, again, this is our root class, if you will. And we want our subchildren to be able to access these variables. So in here, we're going to have a list of nodes. And we'll just call these our children. Because remember, we have this whole hierarchy going on here. So each node can have children inside of it.
Right.
And then let's create another node, and that's going to be our parent.
And that's it.
Yep. Just about it. I do have a few more other things. We have our list, and I forgot to include that.
Oh, okay. Yeah. I was like, wait a minute. No, that's everything we need.
And then we're going to use std. And then list. Oh, and actually one other thing that I kind of totally forgot about is we're going to have basically a list of all the nodes that have ever been created. And why this is going to be useful is basically to store every single node that's ever been created. We can easily loop through our nodes and draw out if necessary or manipulate it. So we're going to create a static list of nodes, node pointers. And we'll just call this nodes. And people from the outside using our node class needs to be able to access it. So let's go ahead and create our list node pointer get nodes. And let's actually hide this under a private section.
Excellent.
Like so let's go ahead and save that out. And let's go over to our transform node. Again, in this video, we're just basically blocking everything in.
That's right.
So our if not defined transform area.
Transform is actually going to be quite easy.
Very, very simple. So our class transform. And now you'll be noticing a lot of inheritance. So :public node, because transform is inheriting from node. Let's go ahead and end that if. All right. So what kind of things do we need? Well, we need our constructor and our destructor.
Now we need some functions, accessory functions, very simple ones. Things like
to access our transformations.
That's right, like set translate, set rotation, set scale.
So we'll pass an X, a Y, and a Z. And our set rotation. And this is basically the rotation in angles around X, around Y, and around the Z axes. And finally we have our set scale around X, Y, and Z. And of course we need to define some public variables, because basically for our transform node we want to be able to access its properties directly from the outside. So we can do a vector3 for our translation, our translate, my bad. Keep getting the two confused. So our vector3 for our rotation, and a vector3 for our scale.
Which really works out good for us, because then we're just going to end up with like translate.x, translate.y.
Which is nice.
Absolutely. Now, of course, we got some includes up here.
Of course, we need to include node.h, because we're inheriting from that. And we're using a vector, so let's go ahead and include our vector3.h. And with that, that should be everything we need for our transform node. So if we go over to our next guy here, our mesh. Remember, our mesh is going to be utilizing our transform node as well, hence why we create our transform first. So our if not defined section, so if not defined mesh underscore h, and we'll define our mesh underscore h and end if. And let me block in my class here, so our public node. And don't forget our semicolon. Did I remember a semicolon in this last one? Yes, I did. Okay, so inside of here, let me go ahead and define our public section. And inside of here, we have our constructor, our virtual destructor, and a few things we need to do. When we have our mesh, of course, we're going to have numerous faces basically tied into our mesh here, and we need to be able to draw it, and we also need to be able to get the transform node associated with this particular mesh.
Well, that's really one of the nice things that we're going to get out of this whole thing, and that is when objects get created, they're responsible for taking care of themselves.
That's right.
Which is really, really nice.
Very, very nice.
What I mean by that is they're responsible for drawing themselves, basically.
And transforming themselves to the proper location, drawing their children, etc. Right. So inside of here, we're going to create a draw mesh function. And I do have a few parameters to this. Basically, do I want to be able to draw my children as well? So a bool draw children. And I'll default this to true, because typically you will want to draw the entire hierarchy. But we'll see cases when we get to creating our interface where this would be kind of nice to be able to control whether or not we draw our children. And we also want to say, draw a particular item. And basically what this means is, I can come in here and maybe I want to draw one of my children, but I called this root node here, and right here I'll say I want to draw some node. And it may not be this node, but it may be one of its children.
Right.
So I'll basically loop through until it reaches that and draw that mesh only. And then let's define our protected section. And basically in here we're going to...
One more big one before we get out of the public area. We need to be able to get our transform.
That's right. And remember, our transform is the class we just created. And we're going to return a reference to it. So transform void. And let me go ahead and throw our include in there.
Okay.
So let's include our transform node. And our transform is including node.h, but I'm going to go ahead and throw our node.h in here just for good measure. And then inside of our protected section, I'm going to define a few variables first. So first off, we have our transform variable. So our transform. And we also want to store... much like in our OBJ loader, we want to store all of our vertices, normals, and UVs, as well as all of our faces.
That's right.
So let's define a vector that contains a list of vectors. And this is going to be a list of vertices. Copy paste this a few times. We have our normals, and finally we have our UVs. And below that, we're going to have a list of faces. And we're going to define faces in just a second here. So with that, we also need a few sort of kind of private functions, if you will, that allow us to simplify the creation of faces.
That's right.
And our geometry in general. So let's create our protected section here. First thing is we want to be able to draw our face. Again, very similar to our, our OBJ loader.
That's right.
Typing and talking kind of.
A little tough.
Yeah.
Now we need to add vertices, add our normals, add our texture coordinates, and add our face.
So basically what this add vertex is doing is adding a new vertex into the vertices array. And we're going to do the same for normals and UVs. So add normal, X, Y, and Z. And we're going to add a text chord as well. Add text chord. And this is just going to be two things, a float S and a float T. Notice we are using a vector 3 for our UVs, even though we're only using S and T. This is simply because we haven't implemented a vector 2. If you wanted to, go ahead and just throw it in. But all it really is a cut-down version of our vector 3 class.
That's right.
So with that, finally, we have our add face. And this is quite an interesting one. So I'm going to type this out a little bit. Basically, in our add face, a face needs... we're assuming that each face has 3 vertices, 3 normals, and then 3 S and T coordinates for each vertex. So basically our add face is going to create a new face and assign the correct vectors to each of those.
Okay.
So it initializes a face for us and adds it into this list. So we're going to pass it 3 ints, which are indices, into these 3 vectors here for our vertex 1, vertex 2, and vertex 3. And same for our normals. Let me just go ahead and tab this over just to keep it clean. So our N1, N2, normal 2, and finally our normal N3. And same for our UV coordinates, UV1, UV2, and UV3. And basically this is going to allow us to easily create a new face for our particular mesh. Now, we've been using face all over the place, so let's go ahead and...
What is a face?
What is a face? So let's create a new face. It's a struct, exactly. And basically all this does is contain 3 vertex pointers, vector pointers for our vertices, 3 for our normals, and 3 for our UVWs. Because each face is basically triangle, one triangle. So our vector 3, pointer, vertices, 3. Same for our normals. And UVs. And then let's go ahead and create a constructor for our face so that it's easy to create a new one.
That's right.
So we're going to create a face, and then we're going to pass it a vector 3, and it's going to be a pointer for X, basically 1, 2, and 3 vertices. So our V1, our vector 3, V2. As you can see, it's very similar to our add face below. So we have our V3, and then 3 vectors for our normals. So N1, vector 3, N2, and vector 3, N3. And finally, same for our UVs. So vector 3, UV1, vector 3, UV2, and vector 3, UV3. And although we said we're going to only define our headers, we'll go ahead and implement our face thing here.
Struct here, okay.
Yep. So we have our vertices. So our first index is going to equal V1. Let me go ahead and copy this. Second is going to be V2 and V3. So 1 and 2. Basically, we're just initializing these 3 arrays here with whatever's passed into us. So we have our normals, N1, N2, and N3. And we'll just copy this whole block here, paste it in, and we're going to have our UVs here. So let me just copy and paste this in here. So our UV1, UV2, and UV3. And basically, our add face function here is going to index into our vertices vector, our normals vector, and our UVs vector, and create a new face for us. So since we're using a vector, let's go ahead and add that in as well, and plus our other things that we need. So let me see. Let me add in my vector.
Okay.
So vector and using std vector.
Okay.
So there's that. And now at this point, we've created our mesh. Let's go ahead and switch over to primitive. Now, this one's a very, very difficult class to create.
It's going to go by in about 30 seconds. Try holding your breath throughout this entire primitive.
Wow, I better type really fast, otherwise whenever I use it, listeners might just roll over and, I don't know.
He's almost done. Almost. Okay, he's taking his time now.
Oh, I'm trying. So basically what we're doing here is creating a virtual function. Basically, as we mentioned before, this is going to be, and that's all there is to it, by the way.
No, except for
include. All right, everyone can breathe now. Oh, I just tried to compile it, and it worked. Basically, this is going to inherit from mesh, and basically it's just a primitive that allows us to create basic things like spheres, cylinders, as we said before. And this is an abstract class because all we're defining is one member function, and we're initializing that equal to 0. So every single child of primitive is going to need to overload our create primitive function.
That's right.
So I'm going to go ahead and save that, come over into our cube, and do pretty much the same thing. Let me copy and paste this. It's going to save a little bit of time. So our cube underscore h. And we're going to need our primitive.h, and this is going to be our cube, and it's going to inherit from our primitive, and it's going to actually define our create primitive.
Click back on primitive.h real quick.
Yeah.
Okay.
All right.
It's all good. I just thought I saw a missing semicolon.
And I do that a lot, so.
Just in case, it's like, corner of my eye. Wasn't sure.
Yeah, you never know.
That's right.
So that's all our cube header file. So let's go over to our plain header file and do the exact same thing, but we're going to add a few accessory functions to this one as well, so a little bit more typing. So inside of here, basically we're going to create a plane, so we're going to have a width and a height, and we're going to allow the user to specify the number of divisions in our plane as well, much like in our lighting demo where we changed the subdivisions of our plane.
Right.
So we're going to allow that same functionality inside of our plane class. So we're going to define a few things aside from our create primitive. A void, let me just tab that over so it's aligned. Set size, we're going to pass it our new width and our new height. And same for our divisions. So set divisions, int divisions. And we're going to define a protected section so that we can define our width, height, and divisions.
Right.
So our float width, float height, and int divisions. So there we go. So at this point, what we need to do is go ahead and try to compile this. But first thing is go over to our SDL demo, include this header file. So let me do an include node.h. Go ahead and try to compile this. And,
very nice.
Wow, it seems to include... Well, the problem is we're not really using our node. Let me go ahead and just define a node in here real quick.
Otherwise, what's getting compiled, really?
Yeah. I think this should force... Actually, it didn't. Let me go ahead and do a new node. And actually, this is not going to work simply because we don't have a constructor. But it seems like the header file for our node is getting compiled properly. And as we start implementing the rest of it, I think our syntax should be just about right. So I think with that, that's going to wrap up this lesson.
That'll work. Thanks a lot.